Hello students, now we are going to compare the three sorting algorithms: merge sort, insertion sort, and heap sort with respect to space-time trade-off. So as you know, the merge sort is the or the heap sort are both the most time efficient algorithms with complexity n log n. But between the two, merge sort requires additional space to really store the elements. So for example, how merge sort works: you input an array, you split it into two halves, and you sort the two halves, but the two sub parts of the array have to be stored separately in addition to the main array. So since you require the same number of space corresponding to n elements, if you're given an n element array, you need another n elements, a space for another n elements to be stored. So that's why we can say merge sort is of complexity theta of n. Given an array of size n, we need another n more elements, space for another n more elements to be stored, right, when you divide the array into two halves and put it there. So that's why merge sort has some space complexity, whereas heap sort doesn't have any space complexity. You rearrange the elements within the heap array itself, as you might look in the materials for heap sort. So we say the heap sort algorithm is in place, that means it doesn't require array memory space that is proportional to the size of the list or the array. Okay, so you say an algorithm is in place if it requires only a constant number of additional memory spaces, or zero memory space. It doesn't require anything that is proportional to the size of the array. Okay, so that such algorithms are said to be in place. Now, insertion sort, it is really not a time efficient algorithm, as you know again from analysis. It requires state of n squared time complexity as average case and worst case number of comparisons. But it's an in-place algorithm because it doesn't require any additional space. There may be some swapping going on, but you can do that with one temporary cell, additional cells. So insertion sort is an in-place algorithm. It doesn't require any additional memory space corresponding to or proportional to the size of the array. Okay, so that's how you discuss the trade-off, space-time trade-off between these sorting algorithms.